Number 25 is talking about people standing in line at an amusement park. And so at noon, we have 500 people standing in line. And then the graph is a graph of the rate at which people are joining the line for a particular amusement park. So if we integrate underneath this curve, we're going to get the total number of people who have been waiting for this ride. So we start off with 500, and then we find the area under this curve. Now, if we use trapezoids, this has a height of 2. So this is going to be 2 over 2, and here we have 2,000, and here we have 1,500. So 2,000 plus 1,500. And then the next interval is 1, and that goes from 1,500 to 2,000. But notice that even though these are the same, the interval is different. So be careful with your units here. And then from 1/2, the next one is from 1/2, 1/2 from 2,000 to 1,000. And then the last interval is from 1,000 to 1,500. And if I add all these together, okay, if I add all of these together, I should get 8,000, and then I have 500. But then people are able to move through the ride at 1,500 per hour. So if we take the total that stood in line plus what we're waiting here, so we have 5,000 and then 8,000 here, 8,000 total, and then minus 1,500 per hour times 5 hours, then we will end up getting a total of 1,000 people. It turns out to be 1,000 people there. And then in number 26, we are talking about water that is coming in and out of a tank. And so it's being filled at a constant rate of 100 gallons per hour. And then it's being drained at the rate that we're given. So if it's being filled at 100 gallons an hour times 18 hours, and then it's being drained, so minus drained at a particular rate, and that's over an 18-hour period. And then we know that it started with 2,500 gallons. So if we add the 2,500 gallons that it had originally, we could put that in the front, it doesn't matter. But then when we add the total here, that should be 2,108.5 gallons. Now, once again, we started with this. This is how much was pumped into the tank, and this is how much was drained after that 18-hour period. And so we end up getting a total of 2,108.5 gallons. Now, 27, we have done problems similar to this using the trapezoidal rule. And the nice thing about number 27 is all of the time intervals are 1 hour. So from 8 to 9 is 1. Trapezoidal rule is delta x over 2. And then the first one would be 120 plus 110. And the next one is 1/2. And then that's going to be from 110. And the next the next height of that trapezoid is 115. And if we just continue until we get to the very end, it would be 110, and then we get 121. Now, if we add all of these together for 27, this should be about 1156.5, and that turns out to be cases here. All right. Now, you're not going to have here, this isn't going to be a half a case, but if we round that up to 57 or leave it at 56, that's fine.